Hi everyone, welcome to Design Upgrade and thank you so much for tuning in. Just wanted to inform you that this video lesson is part of a larger online course which actually itself is one of many other courses that you can find on our main site courses.design-upgrade.com. Hope to see you soon there, and now please enjoy the video and also leave a like and subscribe to the channel if you like the content.
We already know the very basics of Grasshopper, and now we are going to try to create our first parametric truss. So the first thing we need to do is to define the nodes of our truss structure. So let me get back to Grasshopper, and I'm just going to hide this point list component. Okay, so now these are and I'm going to maximize this viewport by making double click into this bar here. So let's assume that these are the points of my lower chord. So if I want to create the points of the upper chord, I just have to displace them in the vertical direction. So in order to move these points, what I need to do is to come to this transform category here, and I'm going to select the move component like that. And we don't need this panel anymore. So what we are going to do is to connect the points that we created here by dividing our first line with this move component. And now this is the geometry that we are going to move. And now we have to specify the direction in which we are going to move this geometry. So in order to do that, we have to define a vector in this vertical direction. And for that, we can come back to this vector category. And here, we can choose, for instance, the unit set vector. So this is a vector, if you take a look here, which is just one unit in the vertical direction. And by the way, I'm going to assume that we have some basic understanding of mathematical operations, vector operations, and so on and so forth. So if we connect this vector with our move component, we can see how we are moving our points in the vertical direction. But not only that, we can also specify the actual length of this vertical vector. So in order to do that, I'm just going to define a new slider, which is going to go between 0 and 5 meters. And of course, this is going to be a real number, not just an integer. So we connect the slider with our vector component here, and now we don't see anything because the slider is 0, but if we update this value, we can see how we are moving these points in the vertical direction. But if you remember properly, these are not the nodes of our truss structure yet, because what we have to do is to remove every 2 points in the upper chord and also every 2 points in the lower chord in order to create the geometry that we are looking for. Which means that now we are going to start manipulating lists in Grasshopper. So in order to manipulate lists, there are several components that we can use, and the main ones are here in the, let's say, in the sets category under the list subcategory. So perhaps the most basic one is the list item. I'm not going to use all of them, but feel free to explore these other components, of course. So for instance, what the list item does is that we are going to connect this point list here, and then we select the index, and we are getting the item with that particular index on the list. So if you take a look into the Rhino viewport, you can see how now we are selecting the point with index number 6. And we can vary the value of this slider, and of course we are selecting different items of this list. But we said that what we want to do is actually to remove points from our list. And whenever we want to remove items from a certain list, we have to come to these components here, the call components. And we are going to remove items based on a certain pattern, which is we are going to remove every 2 items. So for that, we are going to use the call pattern component. So how this works is very easy actually. We have just to connect the list that we are going to manipulate. In this case, it is going to be the upper chord. And let me connect it with this point list component as well to keep track of what we are doing. And okay, if you take a look here, it is removing the first 2 items and it's keeping the next 2 and so on and so forth. And the reason for that is because of this call pattern. By default, this call pattern has 4 values, which are false, false, true, true. And by the way, we are coming across a new data type in Grasshopper, which are the booleans. So a boolean can be either true or false, and they have this value, this symbol here, as you are seeing, this kind of circle. So what we have to do is to change this input parameter in order to keep the points that we want. So in this case, we want to change this by just a true and false value. And now the question that we have to answer is how we can define booleans in Grasshopper as input parameters. So there are different ways to do that, of course, but the most common way is this one. So we are going to come back to this parameter tab here, and under input parameters, we have these 2 guys here, the boolean toggle on the bottom. So let's take a look how this works. If I select, for instance, the toggle, let me get a panel here. So now we are generating a false value with this boolean toggle. And if we do double click into this, let's say, toggle here, we convert it into a true value, and so on and so forth. However, on the other hand, the button works a bit differently. So let's connect it with this panel here. And now we can see that if we don't press the button, it is generating a false value. And if we want to change this value into true, what we have to do is to press and hold this button here. Now it is a true value. And if we release the button, it becomes a false value again. So it seems clear that for our purpose, we are going to use the boolean toggle. So we said that we want a true and then a false. And now, okay, these are our input parameters, and we have to connect the 2 of them with the same input parameter of this call component here. But we can try it, but if we do that, we can see that we are not able to connect both of them at the same time. So if we want to do that, what we have to do is to press and hold the shift key in our keyboard, and now we can connect an additional input parameter into this component, like that. So now you can see that we have true and false as parameters here, and if we select this component, we can see how we are actually removing every 2 points from our point list of the upper chord of our future truss structure. Okay, that's nice actually. And now let's move on to the lower chord here. And here we said that we want to remove every 2 points as well. So one way of doing that is to use the same call component, and I've just copied it with Ctrl+C, Ctrl+V. And now let's connect the points of the lower chord, these ones here. Let's connect them to the point list as well. And now, okay, we are we are removing every 2 points as well, but if we change the values of our booleans here, so if the first one is false and the second one is true, now you can see how we are actually removing every 2 points as we wanted to. Let me escape the Grasshopper definition for 1 second. So we have just explained how we can connect several parameters into the same input parameter of a particular Grasshopper component. And now we are going to see how actually we can remove the connection that we create between certain components. So let's say that we want to remove this wire here. In order to do that, we have 2 possibilities. We can either do right click into this input parameter and then select disconnect, in this case point, or we can also press and hold the control key in our keyboard and we can undo the wire that way. So this is a possibility for deleting the wires or the connections. And imagine that we don't want to delete this connection, but we want to plug this point but into a different input parameter. So to do that, we just have to press and hold the keys Ctrl and Shift like that, and now we can move this wire wherever we want. In this case, let's imagine that we want to connect it to the endpoint parameter. And we could do it just this way. And now let's get back to our Grasshopper definition. And now we are going to start connecting the nodes of our Truss structure. You already know how to manipulate lists in Grasshopper, and now we are going to combine different lists into the same Grasshopper components. So let's start taking a look into the most simple case, which is when the two lists have the same amount of items. So let me get this point list component, and I'm going to copy it to understand a bit better what we are doing. So we have these two lists here. Actually, let's reduce the number of items a bit. 8, that's better, I think. So we have 9 points in its list now. And we are going to get the same line component here once again. Let me call it just by typing it into the canvas. Line, this one here. So let's say that I'm going to connect the points of the lower chord here with the ones of the upper chord, like that. So as you can see, we are getting this line, that what we are doing basically is connect the first item or the item with index 0 with the item with the same index of the other list, and so on and so forth. Okay, but this is very simple. And now what would happen if we were connecting lists with a different amount of items? So for instance, let's get this lower chord, that's right, but now let's get this list of the upper chord, which has just half of the points. So if we do that, but let me get this point list updated. So Grasshopper is connecting the points with the same index, and then when we run out of items in the shortest list, it connects this last item with the remaining items of the longest list, like that. So we are connecting this item with index 4 with the remaining items of the longest list. Okay, so that was a basic introduction, and now let's start creating our diagonals. So let me connect this with the lower chord, and now we have to define the diagonals. So if we, as we said, if we connect these two lists like that, so let's see here and here. Okay, this the first lines look really nice, that's what we are looking for, but then we have this additional line here and we don't like it at all. So what we have to do is to remove this line, or better said, we have to remove this last item from this list of the upper chord. And if you remember, whenever we want to remove certain items from a list, we have to use the call components. So let's get back to this set category. And now we are going to choose not the call pattern component, but the call index, because we are going to select exactly the item that we are going to remove from our list. So we have to select the points in the upper chord. And now we have to select the last item. And how can we do that? Okay, now this is the number 4, but imagine that we were updating the number of nodes in our Truss structure. So this would be perhaps instead of a 4, a 5 or a 6 or something else. But we can use a trick. The trick is that if we have this first index and 0 and we go backwards, we can get into the last item, which means that if I say -1 here, if we type this -1 into quotation marks, what we are going to do is to define it inside of a panel, but it's the same for us. Now you can see how we are removing actually this last item, and this is happening because we have this graph parameter set as true. Otherwise, we couldn't, let's say, get backwards to the last item as we have just done. Okay, so now actually we are ready to connect the points of our upper chord and lower chord, and you can see how we are getting our first diagonals this way. And now, of course, we want to get the diagonals the other way. So for that, what we have to do is to remove not the last item as we did just here, but we have to remove the first one. So let me try to keep this a bit clean. we don't want this anymore, I think. Yeah, that's right. So now we have to remove the first item. So I'm going to copy this call component here, and I'm going to change this -1 by a 0. And this is inside of a panel, but it works as a numeric value as well, because this is what our component is expecting. And now if we connect this modified list with our point list component, we can see how we have just removed the former first item of our list. And now we are ready to connect the nodes once again. So we get the points of the lower chord and the points of this modified list of the upper chord. And now we can see how we have just defined the remaining diagonals of our truss structure. And now we have to define the segments of our upper chord and lower chord. So it would be very easy to just connect the endpoints of our chords here, but if we were going to analyze this structure, that probably wouldn't work very well with the calculation program. So instead, we're going to define different segments for between the nodes of the lower chord and upper chord. So let me start with the upper chord, and I'm going to connect this point list with this other modified list, let's say, or called list that we used for defining our diagonals. So like that. Because if you take a look, actually, we have this list with index 0 here, and the next list has the index 0 in this point here. So if we connect these both lists, actually, what we are going to do is to create a segment from this first index to this first index from the other list here, and so on and so forth. So 0 with 0, 1 with 1, 2 with 2, and 3 with 3. Let's see if that is happening. So let's get the line component once again, and let's connect this first list with this other list. And yeah, that's right. So if we take a look here, we can see how we are creating just for line objects, and these are these lines in Grasshopper. So it seems like everything is working fine. And now let's move on to the lower chord. So first of all, let me hide the original line that we used to divide our to get our nodes here. So I'm going to hide it like that. And now let's get our point list connected to the lower chord right here. So this is a bit tricky because we have this list here, and we want to offset it as we did before. So first, of course, we want to remove the last item as we did. Like that. And now, okay, 0, 1, 2. And the other option would be, as we just did before, to just delete the first item, and now we would get the remaining ones, and as we did on the upper chord. But I'm going to show you a different approach, which is actually using this shift list component. So if we do this, what we are going to do is to define a certain offset to for a list of points. So in this case, we are going to get this original point list from the lower chord, like that, and we are going to offset it so the 0 is no longer here but here. So let's try to do it. We have to connect the point list with our shift list component, and okay, now we have to specify the offset, and by default this value is 1, which is actually what we want. And now let's see how this looks. So these are our point list, and I'm going to replace the input list here. And now you can see how the 0 has shifted from this point to this point, and so on and so forth. So let's say that this part of the of our nodes of our list, and this is what we were looking for. But we have this point here, which was our former last point, but it's now at the beginning, and we want to get rid of that. So what we want to do is to turn this grab parameter into false. So let's define a boolean, or let's get a boolean to do that. So this is false, and if we set grab to false, we can see how we get this list here. And let me get the point list once again. And if we connect the point list with the points of the lower chord, we can see how now, let me put this a bit more clean like that. So we have these two lists of points from the lower chord, let's say, and we can see how now we can connect the 0 with the 0, the 1 with the 1, the 2 with the 2, and it should make sense. So let's try it. Line component, this guy with this guy, and we have our lower chord here, which is made of 3 line objects. Okay, so I think our truss structure looks really nice. Let me hide the point list. And by the way, if we want to select several components, we can do it pressing and holding the Shift key or the Control key if you want, and then doing right click into the canvas and just selecting preview off. Okay, so this is our truss structure, and just to finalize, let's imagine that we were importing it into another calculation program. So these are our members, let's say, and we would need to define the supports as well. So let's imagine that the supports are these 2 points here. And as we said, in order to get items from a certain list, we have to come back to this set category, and we're going to use the list item for that. So we need the points of our upper chord, these ones here, and we're going to select the first item and the last one. So this is, by default, this is index 0, and this is this point here. And now we want to select the last one. And in order to do that, a very interesting approach is to define a -1 inside of a panel like we did before. And now we would have also our supports of our truss structure. And now, of course, we can try playing with our input parameters to see how we can modify the geometry of our parametric truss. So we can try selecting the points in Rhino and moving them around with the gamble, and of course you can see how the truss geometry is adapted to this new position of our endpoints. And of course we can also try playing with the height and varying it to see how also changes the truss geometry, and we can even try modifying the number of subdivisions of our truss structure with this slider. But if we do that, we can see that it doesn't work now. Okay, now with 10 it works, with 11 it doesn't work anymore, and so on and so forth. And the reason for that is that we need 2 additional nodes to define a new, let's say, cell for this truss structure. So what we have to do to finish our Grasshopper definition for this parametric truss structure is to make double click into this slider and select the option that we can choose only even numbers, like that. So now it can only be 10, 8, 6, and so on and so forth. So now you can see that we can play around with this slider, and the geometry or our truss structure makes sense every time.